Welcome back, everyone. For this next part of the lesson, we are going to be focusing on geometric series. I've done arithmetic series in the past, but now we're going to be focusing on what happens when I add the terms of a geometric sequence together. Let's look at the definition of a geometric series. So guys, a geometric series is formed when the terms of a geometric sequence are added together. So just a reminder that a geometric sequence has the main property of a common ratio. The example given below with 3 semicolon negative 9 semicolon 27 semicolon negative 81, semicolon 243 going on is a geometric sequence. Please just remember, because this is a list of numbers, the list is indicated with semicolons, it sometimes may be indicated with commas. Because it is a list, it is a sequence. But underneath that, you can see 3 plus negative 9 plus 27 plus negative 81, plus 243, plus negative 729 is a geometric series. It is actually a series because I am adding the values of the geometric sequence together. So because it is a sum, it is a series. Wonderful, guys. I just want to make sure we've clarified that. A geometric sequence is a list of numbers where there is a common ratio between terms. A geometric series is a geometric sequence, except I am adding the values of each term together. Let us look at what we can use as a formula, or what is the formula of a geometric series. So, when I have Sn, please note that Sn refers to the sum or a series. So what I've listed over here is the sum of the terms of a geometric sequence added together. So I have A plus A times R, because I know that term 1 is A, term 2 will be A multiplied by the common ratio once, and then term 3 will be A multiplied by the common ratio another time. So AR squared is the same thing as T3, going the whole way up to A to the power of AR to the power of n minus 1. And the n minus 1 is indicating that this is the last term of the actual geometric sequence. So this is the list of adding all of the values of a geometric sequence together, because I've got A plus AR squared going the whole way up to adding AR to the power of n minus 1. What I've done in this next line and what is needed to derive this formula is I've multiplied Sn by R. So all that you're going to see is that the difference is that A has been multiplied by R, so it's AR. AR has been multiplied by R, so it's now AR squared. AR squared has been multiplied by R, so it's now AR cubed. Going the whole way up to where AR to the power of n minus 1 has been multiplied by an additional R, so it's AR to the power of n. So how this helps me get my formula is I'm now going to say Sn minus Rsn. If I do that, what's going to happen is essentially I'm taking this top line and I'm subtracting the values of the bottom line. We are going to have a lot of cancellations. So if you're thinking about the top line subtracted by the bottom line, AR will cancel, AR squared will cancel, going the whole way up to AR n minus 1 will cancel. So everything is going to cancel except for the A and the ARN. So Sn minus Rsn will leave me with A minus ARN, as those are the only terms resulting from the subtraction. Then in the next line, if you take Sn out as a highest common factor, you're left with 1 minus r in the brackets. On the right-hand side, I've taken a out, which has left me with 1 minus rn in the brackets. So Sn will be equal to a 1 minus r to the power of n over 1 minus r. So that is actually how I define the formula for a geometric series. So please note that this can be written in two different ways. So we can have Sn is equal to a times 1 minus rn over 1 minus r. So this is one of the options, but this means the exact same thing as Sn is equal to a r to the power of n minus 1 over r minus 1. Both of these are going to help me find the sum of a geometric series. So please remember this is a geometric series example. But you might be asking, how do I know which one to use? It actually doesn't matter which one you use. However, there are preferred examples. So when r is particularly larger than 1, this example or this version of the formula is used quite a lot. And when r is less than 1, the first version of the formula is used. But if you like one version more than the other, that does not matter. Lastly, I just want you to note that r is not equal to 1 for geometric series, as this would lead to the denominators being undefined, as we would then have 1 minus 1, which would be 0, and 1 minus 1 again. So please note that these formulas are used for geometric series when r is not 1. Great, everyone. So I've now defined that a geometric series is when I add the values of a geometric sequence together. After the break, I'm going to look at specific examples of geometric series where I can use the formulas that I have just derived. See you soon.